Hi everyone, this is Infinity YouTube channel. Please remember to like, subscribe and share. So today we are going to deal with a topic called analysis of variance, popularly known as Anova. The analysis of variance provides ways or methods for comparing several population mean. So we shall be discussing one-way Anova in this video. So in that one-way Anova, we are going to discuss the F-test distribution, which is used for the analysis of variance. So there are several formula that one needs to know in order to compare the analysis of variance. So the first formula that we need to know is the F-test calculated distribution. So the F-test calculated distribution is F equals MSB divided by MSW. Okay, where MSB is the meaning of MSB is variance between samples. So this is the variance between samples. Variance between samples. And MSW is variance within samples. Variance within samples. All right, so this is the F-test calculated value. Okay, this is the formula to use. Then another formula we need to know is this MSB. What does it mean? So MSB is actually equals to SSB divided by K minus 1, where SSB is between sample sum of squares, and K minus 1 is the degree of freedom. K minus 1 is the degree of freedom of the numerator. So then the next we need to know here is the MSW. So the MSW is actually equals to SSW divided by N minus K, where SSW is within sample sum of squares. And M minus K is degree of freedom of the denominator. All right, so also there is a relationship between SSB and SSW, and the relationship between SSB and SSW is SSB is equals to SST minus SSW. Okay, so this is the relationship between SSB, SST and SSW. So this SSB is actually equal to the summation of SSB is actually equal to T1 squared divided by N1 plus T2 squared divided by N2 plus T3 squared divided by N3 till Tn squared into n subscript n minus the summation of x all squared divided by n. All right, where t, the t1 or the t subscript n, is given as sum of the variance in each of the samples. So let me use t1 as an example. T1 is sum of the value in sample 1, sum of the value in sample 1, and of course T2, T3 is sum of the samples in sample 2, sum of the values rather in sample 2, sum of the values in sample 3, and so on and so forth. Then the smaller subscripts below it, the n here, let me use n1 for instance. So the n there is actually size of each of the samples. So you can say size of sample 1 as n1, size of sample 1, size of sample 1, and of course n2, size of sample 2, and n3, size of sample 3. So the n here, this other n here, is, you can call it the overall n. Hence, the n there is actually equals to this number of values in all samples. So this is the number of all values, the number of values in all samples. So the number of values in all samples can be equated as n1 plus n2 plus n3 plus till infinity, depending on the numbers of samples that you have. So that is for SSB. Now SSW is actually equal to the sum of x squared minus t1 squared over n1 plus t2 squared over n2 plus t3 squared over n3, of course till infinity, depending on how many samples that you have. All right, so where okay, I didn't define the meaning of this term. So this summation x is actually, summation of x is equal to sum of values in all samples. Sum of values in all samples. That is the sum of all values, sum of all values in samples. Sum of values in all samples. And is actually equals to T1 plus T2 plus T3. And summation of x squared is actually equal to the sum of squares in all samples. Sum of squares in all samples. All right. So these are the terminologies that you need to know in order to understand the analysis of variance. So we are going to solve further example to utilize these various formula that we have. So I hope the video was useful and helpful. Please remember to like, subscribe, and share. Thank you so much.